Welcome back. This is Leshire Math. Now let's consider question number 3. Question number 3 says that the first four terms of a sequence are 3, negative 6, u3, negative 24. Continuation. Part A, decide showing detailed reasoning whether the sequence could be Roman 1, an arithmetic sequence, Roman 2, a geometric sequence. State for each part the value of u3 if such a sequence is possible. Then of course part B, you'll be required, the part B says that given instead that the sequence is periodic of period 4 and also the sum of the first 50 terms from I equals to 1 to 50 equals to 141, then find the value of u3. Now we can start with the part A. We can start with part A. Part A, we want to do what we call arithmetic sequence check. Now, listing what you've been given here, you've been given 3, negative 6, u3, negative 24. Now from this we can say that, of course we know that this is the first term denoted as u1, negative 6 is the second term, u3 takes the third term, and negative 24 takes the fourth term. Right, so we can say that by arithmetic sequence, we know that the common difference is gotten by finding the difference between the consecutive terms. Like in this case, we can say that either if arithmetic then u2 minus u1 should give us the common difference, and if we substitute, u2 is negative 6, u1 is 3, then this means negative 6 minus 3, which is equals to negative 9. So we can say that D is equals to negative 9. On the same note, if this is true, then we can say that u3 should be given as u2 plus the common difference, because we know that for us to get the third term in this case, we'll take the previous term, that is u2 plus the common difference, and this means that, or translate to, u2 is simply negative 6, common difference is negative 9, so we'll have negative 6 minus 9, and this one gives you negative 15. We can also get u4, the fourth term. We know that the fourth term in this case, similarly, is just the same as the third term plus the common difference. And in this case, if we substitute the third term that we've determined is negative 15 plus the common difference, which is negative 9, and this one gives you negative 24. So this matches the given value in the sequence. So here we can, maybe to use a different pen, we can say which matches given value. So you realize that this work, so this means that an arithmetic sequence is possible. So conclusion in this case, we can say this works an arithmetic sequence is possible with u3 given as negative 15. So that is the solution for part A, Roman 1. We can also consider Roman 2. Roman 2, we also need to find out if the sequence is geometric sequence. So in this case, we can say that having geometric sequence check. So we know that if this sequence is geometric, normally we are required to find the common ratio. And how do we find the common ratio? Common ratio is determined by the ratio of consecutive terms, that is the ratio of the preceding term divided by the ratio of the previous term. So in this case, we can say if geometric sequence, or if geometric, then it means that the common ratio can be given as either, if we pick the first two, that will be u2 divided by u1, or common ratio, we pick the third term and the fourth term, then r should be equals to u4 divided by u3. Now just to substitute what we have, in this case we'll say that r will be equals to u2 over u1, and u2 from what we have here, u2 is negative 6, which is the second term, and the first term is simply positive 3. And when we simplify this, this one is simply equals to negative 2. So it means the common ratio is equals to negative 2. If that is the case, then it means for us to get the third term, then your third term in this case will be equals to the second term, which is u2 times the common ratio. And this one is given by the second term, we know it is negative 6. The common ratio is simply negative 2. And getting this product simply gives you 12. On the same note, for us to get the fourth term, we'll say that the fourth term, which is u4, is also given as the third term, which is u3, multiplied by the common ratio. And when we substitute what we have, then it means we'll have the third term is simply 12 times the common ratio is negative 2. And this one gives you negative 24. So here we can say that this negative 24 as the fourth term, it matches the given value. So what is the conclusion in this case? The conclusion which we can give that this also works. This also works. A geometric sequence is possible with u3 being equivalent to 12. So this one marks the end of part A, Roman 2. Now we can also consider part B here. Going back to the question, what does part B say? Part B says that given instead that the sequence is periodic of period 4, and the sum of the first 50 terms is given as 141. Find the value of u3. Now there's something quite interesting in this case, is that the sequence is periodic. It means it repeats itself after 4 terms. So what does this mean? Let's find out. So for part B here, part B, we'll use a blue pen still. Part B, we can say that since the sequence is periodic, with period 4 the terms repeat us. So if you look at what we've been given, it will be 3, negative 6, u3, negative 24. It starts again, 3, negative 6, u3, negative 24, in that order. So it will be repeating after every 4 terms. So this means that we can try and get the sum of just one period. What is the sum of the first 4 terms? That gives us the sum of one period, because if it repeats itself, then from this we can say that the sum of one period, the sum of one period is given us. It will be 3, of course 3 minus 6 plus u3 minus 24. Collecting the like terms, this one can be simplified as of course 3 minus 6 is negative 3, minus 24 is negative 27. So this one means we'll have u3 minus 27 as the sum of one period. Now, what we can do at this level, we can split the sum to 50 terms. That is, out of the 50 terms, how many complete periods do we have? So from this, we can say splitting the sum to 50 terms. We know that 50 terms in this case equals to 50 terms is equivalent to how many 4 periods are there? Of course, 50 divided by 4 is 12 plus 2 extra terms. So we can say that this one is equivalent to 12 complete periods. 12 complete periods. Of course, that gives you 48 terms. Then plus 2 extra terms. Call this, in this case, the first term and the second term. Now, if we substitute what we've been given, then it means the sum of the first 50 terms will be equals to 12 times the sum of one period, and the sum of one period is simply given as u3 minus 27. Then we add to u1, the sum of the first and the second term, so we add to 3 minus 6. The sum of the first 50 terms already we've been given as 141, so this means we'll have 141 is equivalent to 12 multiplied by u3 minus 27 plus 3 minus 6. So simplifying this, we'll still say that 141 equals to, opening the brackets, we'll have 12 times u3. This one is the same as 12 u3 minus 12 times negative 27. Let's find out. So we'll have 12 times negative 27. This gives you negative 324. Then 3 minus 6 will be minus 3. So still collecting the like terms, we can say that 141 should be equals to 12u3 minus 324 minus 3 is the same as minus 327. Collecting the like terms where possible, we'll say that this means that 12u3 should be equals to, of course this is negative, when it crosses the equal sign becomes 141 plus 327. So continuation here, we can have our calculator and add this. Of course we'll have 141 plus 327. This gives you 468. So therefore we'll say that 12u3 is equals to 468. For us to remain with u3, we can divide by 12, divide by 12. Let's get the calculator still. So our answer here, we can divide by 12, and this gives you 39. So this means that u3 is simply equals to 39. And this is the solution for part B, question number 3.